Let's work on problem set 14, problem 2. We have a mass suspended by massless and extensible strings, unequal length through walls, as illustrated. We need to find the tension in string 2. First thing we want to do is label the drawing. We have a gravitational force, mg, acting down on the mass, tension T, 2, string 2, tension T1, in string 1. Those are all the forces we have, so we can do the free body diagram. The object here, I need to pick a coordinate system. We'll use standard XY coordinate system here. And now we can put in the forces. mg, T2, and T1. Make sure that we label the angles. And since T1 and T2 go off at angles, we're going to have to do the component drawing. Let's go ahead and do that. We're going to have this component of T2, T2 cosine theta 2, this component, T1 cosine theta 1, mg, T2 sine theta 2, and T1 sine theta 1. At this point, we can write our Newton's second law equation. And in the x direction, that will be T2 cosine theta 2 minus T1 cosine theta 1 equals m a sub x. In the y direction, T2 sine theta 2 plus T1 sine theta 1 minus mg equals m-a-y. Since the object is at rest, both of the accelerations are 0. Perhaps the easiest way to solve this is to take a look at the x equation and solve for T1. If I do that, then I get T1 cosine theta 1 equals T2 cosine theta 2, or T1 equals T2 cosine theta 2 divided by cosine theta 1. Let's take this value for T2 and substitute it into the y equation. Doing that, I get T2 sine theta 2 plus T2 cosine theta 2 sine theta 1 over cosine theta 1 equals m1g. Let's factor out a T2 and simplify the left-hand side. And I get T2 sine theta 2 cosine theta 1 plus sine theta 1 cosine theta 2 divided by cosine theta 1 equals m1g. The sine and cosine function in the numerator here is just equal to the sine of the sum of the two angles. So I can write this T2 times the sine of theta 2 plus theta 1 divided by cosine theta 1 equals m1g. And we are done. This gives me T2 equals mg cosine theta 1 divided by sine of theta 2